Get up there. There we go. Cool. All right, so this, what I'm about to put up on the board, is all you're allowed to have on the formula sheet. So we'll open it up to your suggestions. There's not that many formulas, so almost can't go wrong. So you can have the words formula sheet if you want. Yay. Let's see. So the whole chapter 1 is definitions, no formulas. So chapter 2, you have to know the class width formula. Right? If you didn't know it for this last quiz, make sure you know it for the test. What is the class width formula? How do you figure out why your classes should be? Yeah, range divided by number of classes. I love it. So you got to know that. So really, I mean, if you almost don't want to put these down, but you can. In fact, on the test, I want to see work. Meaning, I don't want to just see mean is 48.2. I want to see a little bit of work to get to it. Right? You don't have to write all the numbers down and add them up in a column like you're in Math 88 or shit. But you have to show me where something's coming from.
Can you put class width formula and then that one?
No.
Or just...
What did I say about the class width? What did I say about it? The class width, you have to know it. Yes, all right. So you can't write that down. I like it. Professor's like, damn it. Now, what's the formula for this one? What is this?
Mean
Of the sample. I like it. This is Greek letter, so it's population. This is our letter, so it's sample. The formula for it is the same damn formula. I think the book uses a big N. N is always just N. It's just the number of things. Okay. So far, so good. Remember this thing. So you can't put next to this population mean. Right? Can't put mean next to this. No words. And then what do we got? I'm going to let you put down, you got to understand mode. No formula for that. There is a formula for the median the book uses, but remember the median is just going halfway through the list, right? Let's see. Mid-range. So what's the formula for the mid-range?
High plus.
Good. High plus low.
Divided by 2.
Divide by 2. I like it. The range you got to know. You just got to know how to get the range. Sorry. I'm not really sorry. I'm sorry. Let's see. Anything else from that section? No. I like it. Percentiles is a process you have to know how to do. Okay, there is a... let's see. I could... no, I'm not going to let you do that. You got to know how to do that. If you use the book formula for finding out what percentile a number is in, you can write that down. I'm not even going to talk about it. It's up to you if you want to use it or not. You don't have to. All right. Let's see. Then we have standard deviation. I think that's the next. What is this, though?
Variance.
Variance of the... It's Greek, right? That's not one of our letters, so that's the variance of the population. Right. It's all using Roman numerals for Super Bowls. It's the same thing. Oh, it's a Super Bowl, Roman numeral, you know. So we're using Greek letters for big, population. Yes, no, maybe so. So that's going to be this little. What's going to go here? No.
Oh no.
Population.
No.
Cool. I like it. Squared, remember, because you got to kill those negatives. Divided by n. When does n minus 1 come into play? When it's an adjustment, because it's just a sample. I mean, what letter would be here if it was a sample? Standard deviation.
S.
S. I like it. Sigma is lowercase, this is lowercase sigma, which is S. And it's standard deviation, that's why we chose that letter. Ooh. If you want to, do you see how these are really the same formula? Does anybody see that? Here I haven't square rooted yet, here I square rooted. Ooh. Right? If you want to, you can write that down. They really are the same formula. If it will help you, you can write both of those down. And then right below that, I would say S squared. Now what's going to go here?
X bar.
X bar. Because now I'm talking about a sample. And down here is going to be, that's an adjustment because it's just a poor little sample. It needs some help. Poor little dude. So underneath that, if you want to, you can write big ass square root. I haven't taken a square root yet. I have taken a square root. So this is the sample variance. This is the sample standard deviation. I like it. Any other suggestions that you think should be on this sheet? If you're honest, I hear some people going, all kinds of stuff. But anything else you think that I've left out? It's always possible. My memory's going. Too much shit in my head. No? Everybody's cool with just this? I might have left something out on purpose, but I don't think I did. Okay, so this is the formula sheet then. You can't have anything else on there besides these, except for that one percentile formula from the book if you want to write that down. If you didn't use it for the homework, don't write that shit down. It's just going to mess you up. No notes, no examples, nothing. Right? You can write this on a normal sheet of paper. In fact, in the final, you can bring all your formula sheets with you. As long as you don't bother anybody, I don't care how big of a stack you got of formulas, as long as they are just formulas. Right? I don't make you do a note card. I always joke that it would be like a grain of rice. Write all the notes you want to on a grain of rice. Oh, shit. You never heard of that, writing on a grain of rice? Yes, some of you guys have, and you're like, it's too early for laughing. Okay. Plus, it wasn't funny. Oh, shit. Okay. So now I'm going to open it up for, I know we're going to do another example of standard deviation. Right? And then we want to do an example of like a z-score thing, because we kind of rushed that at the end of last time. So why don't we do that first, and then I'll open it up to whatever questions you guys have specifically. Is that all right? Yeah. Okay. So let's do, let me make sure, has everybody got these written down? Give myself some more room. All right. Okay, so let's do an example of standard deviation. So let me make up some data. Let's make it a relatively small group. So in the practice test, there was like a relatively large set of data. So that kind of table for this kind of took a little space and so forth. On the actual test, I'm going to give you maybe up to like 12 or something data points. I guess it's about the same size. Nothing too horrible. But here, let's just do a few. Maybe make it come out semi. Okay. So the question would ask you, well, more than likely it would say find the mean, median, mode, just like on the test. So you go into this already knowing something you obviously need. Is this a sample or a population? I know I didn't say, but I kind of give you a hint. Is this a sample or a population?
Sample.
How do you know? Yeah, all right, so in the problem, I've got to say 87 people were sampled, or 12, hopefully not 87. Or I have to say the population data is as follows. I have to be really clear if it's a population. In statistics, if it doesn't say, you assume sample, because it's what we almost always have. If we have a population, we're going like, holy shit, I got a population. You're going to scream at everybody, I got a population, holy shit. Because you normally just have a sample, right? So help me out. What's the mean? What's the sum of these?
95?
They add up to 95?
I think. Yeah.
47, 95, okay. No, not 95. Let's see. 10, 20, 30, 40, 57. Jeff, there you go. 57. So 85, right?
Oh.
Is that cool? Is that right? It's early. 10, 20, 30, 40, 60, 72, 80. That's even better. Okay. That's what I was going for, was a whole number. Yeah, that works out. Sweet. So how do I get the mean? How do we get X bar?
80 divided by 16.
1, 2, 3, 4, 5.
16.
Yeah, so 16. I like it. So the mean came out to be 16. On the test, I will tell you what to round the mean to, if it might come out to be a decimal. Because there's a big thing, if you round it too much, everything you do is going to be off. That sucks. So I'm going to try to tell you how much to round it to that will keep it decently close to the right answer. How are we doing so far? Nothing amazing has happened yet. Right? So now what would I put here then?
86.
Yeah, 10 minus 16?
-6.
-6. 12 minus 16?
-4.
-4. Real quick, watch this. Do you see how that goes up 4? So that's going to go up 4. See how that goes up 3? That's going to go up 3. See how that goes up 4? That's going to go up 4. 23 minus 16 is 7. 19 minus 16 is 3. Blah, blah, blah. Or just subtract the position. You can also do, remember, L1, L2 would be L1 minus 16, right? And then just copy the stuff down into a table so I can see what the hell you're doing. And if you're uncomfortable with the calculator, that's bad, but you can still do each row by hand. That's fine. I'd rather let this $100 machine do it for me. It's pretty decent so far. It's just, remember, the whole idea behind this was to see how far each data point was so that I can then average those. But why do we have this next column? Because these are always going to add up to be. These are always going to add up to be. What do they add up to be? 0. Because there's going to be equal amounts negative as there are positive. You see negative 10 and 10. Shit. So I'd always get 0 for this number. How's that useful? So we square the thing, so at the end I have to square root. You can see how everything kind of comes together. Hopefully. So what do I put here?
36.
This is where you got to be real careful. I see so many people put negative 36 here because they do that in their calculator. This is calculated correctly. You guys understand that?
Yeah.
Because I'm not squaring negative 6. I'm squaring 6 and then putting a negative on it. This would come out right. Because now I'm squaring negative 6. So this is positive 36. 10, 9, 49. And now I add them up. Can you guys put the symbol for what the hell we're doing when we add them up? Can you write the symbol right there for me? Don't say anything out loud. Don't say anything out loud. I love you guys. I wasn't that loud, Jeff. No, just nothing out loud at all. So what do you get when you add these up?
110. 110.
Yeah, 110. And what is that in symbols? Now you can say it. So this thing equals 110. So anywhere I see this thing, I can replace it with 110. So I look at my formula sheet. I know it's a sample, so I get my S. People start putting shit in here that doesn't make any sense. I need the sum of these. That's what that says. So, of course, what do I put on top? 110. Because what did these add up to be? They added up to be 110. See, this is 110. This is 110. And what goes on the bottom?
4.
4. You got 5 data points, minus 1 is 4. What's that? 27 point, what is it? 27.5? Yeah. Let me stop again. Is everybody with things so far? This is the day to get questions out. Okay. And then what I have to do to get the actual, what is that at the moment? What is that? That is the variance. So to get the standard deviation, I just have to square root that thing, kill that square shit we did. Right? This is number of dogs somebody owns. Whoa. Then this is square dogs. Oh. What? So I got to square root it to bring it back to normal. And who remembers how far to take the standard deviation, how much to round it to? 3 decimal places at least. So if you use 4 decimal places, hey, it's even better. 2 decimal places, shit, you're going to lose points. If that angers you, just don't stop at 2. Go to 3. So what do you guys get here? 5.2, 4, 4? Okay. What does that mean? How far each data point gets away from the mean on average. I like it. So that's why I call standard deviation steps. If my data, I'm going to use this as my step size to get through the data. So if my data looks like this, I'm going to use kind of a bigger step to walk around in it. Walk around and like, oh, look at that shit. If my data looks like this, wah! I want my steps to be tiny. If I take a big ass step, I missed the whole data. I'm like, oh, there's nothing here. No, yes. So I call standard deviations very often, I call them steps. Don't put step on the test when I'm asking you a formal question. You with me? But the concept of it goes right into the idea of steps. I also think of it as this sets up what each tick mark means. And then I can see how far apart 2 things are relative to this. That's what we call the z-score. So if I said, how many standard deviations from the mean to the data point of 19? So if you want to, you actually, I'll tell you what, I'll go back and amend the earlier thing. You could put this formula down on your formula sheet. This one and this one. They're the same formula. Do you see that? Data point I'm curious about minus the middle divided by the spread. That's reading that in English. Now the concept behind this is how many of these fit in there? How many standard deviations are there from the mean to the data point? That's what that really means. So z-score is a number of steps to get to something. Maybe. So if I'm saying how far away is the next town, I'm going to use miles. Or if you're in any other country on the face of the earth, you'll use kilometers. Right? If I'm going to ask you how far away I am from somebody in this room, you might use feet. You're not going to use frickin' miles. If I went 1 mile, I am out of the room. Right? You see how that comes together? So standard deviation is the fundamental unit I use to measure distance in data. Z-score is the measurement I get. So what do you get for this? What's this going to be? What's the data point I'm curious about? 19. What's the mean? 16. And what's the standard deviation?
5.244.
Now I know already the answer. How far away is this? It's only 3 away. Is it a full step away? No, so my answer should come out less than 1. It's not even 1 step away. So what do you guys get? What's 3 over 5.244? 0.5. What?
0.5720.
Sorry?
5.5720.
0.572, blah, blah, blah. Okay. So this would be, if you took it to 4 places, it'd be 5721, is that right?
Yeah.
Okay. Yeah, I like it. Later we'll see that we'll round these to 2 places because we're going to use a certain chart to look things up, and they only go to 2 places. But right now, I don't care, it's fine. So this means a little more than half of a step away from 16 to 19. So I would take half a step and go, oh, there I am. Just about a little over half a step from 16 to 19. We're not used to talking about math in this way, but statistics is a really good show of using mathematical ideas to directly talk about real life shit. Right? In algebra, you have somebody that forgot how much money they put in the bank. You remember those problems? Joseph forgot how much money he put in the bank. He put 1 and 5%. And like, what the flip is this Joseph do? What kind of problem? I love that problem. How much money do I got? I don't know. I know all too well how much money I have. All right. So one last application of this real quick, and then I'll open it up to whatever. Let me leave this here. There's the standard deviation. Here's the mean. What is 1 standard deviation up from the mean? Where do I get to if I take 1 step up? How do I do that? I take 16 plus this. Yeah, so 21.244. And if I take 1 step down, so this is plus 1 standard deviation, this is minus 1 standard deviation. 10.756. I like it. Is that making that? Was that hard? How do I describe what I just made? What would it look like to tell you to make this within 1 standard deviation of the mean? Isn't that this? If I said guess my weight within 5 pounds, that means you could be off by 5 in either direction, right? Up or down. So within means go both ways by that much. Is making that's on that sheet we did, right? That idea of making this little picture. Can somebody tell me how many data points I just caught in that net? Did I catch 10?
No.
Where's 10? It's outside the net.
Yeah.
What about 12?
Yeah.
Oh yeah. What about 16?
Yeah.
Well shit, yeah. What about 19?
Yes.
Yeah. What about 23?
No.
Nope. So what percentage of the data did I just catch? How many?
6 over 5.
3?
3.
3 data points
Yeah.
out of 5 total. 60%.
60%.
Beautiful. So that's what I ask you. If I say what percentage of the data is within 1 standard deviation, you go, oh shit, within 1 standard deviation. Let me make this picture for myself and just see how much of the data I catch. There's an example on that worksheet we did last time. Yeah. This idea of within 1 step, within 2 steps, how much data is there, that's a huge idea. I love this because this is a concrete. You can go count and see exactly. And then there's all these theorems about what happens if you have this kind of distribution and that kind of distribution. But it's nice to go, this is what I freaking see. Right? It's not a theorem. I can actually calculate this shit. Okay, so I'm getting us ready for some of these theorems so you have a better idea of what the hell they're talking about. Okay. All right, so now I'm going to open it up to whatever you guys want to talk about. You can ask questions about this if you want to, or, yeah.
How do we get the 5 number summary?
Okay. Oh, man, I brought 0 to drink. That's awesome. Does anybody have a question about this before I take it away? Yes?
I just need a second to read it.
I'm sorry, do it again?
I just need a second to read it.
Oh, yeah. I'll just take up the table. Anybody remember what the 5 number summary is? Low.
Isn't it like the minimum, the maximum, and then like first quartile 1, medium 2, 3, yeah.
Yep. So I don't know, do you want to do an example like this, or? All right. All right, so we got this here now? I'm sorry, who's? I don't want to rush you, you're fine. You got it? Okay. So let's make up some data. Let's put it in order. All right, so basically if your data's out of order, you almost always want to put it in order. Because a lot of things requires that. All right, let's play. Let's use that data. Data. All right. So 2 of these are really easy as shit. What's the lowest one?
90.
No way. And what's the highest one?
144.
That's crazy. Okay. How do you get Q1? What's another name for Q1?
20% off.
25th percentile. I like it. 25% of the way in. Well, how long is my data?
8.
Yeah. So I take 25% of 8. 1/4 of 8 is 2. What do I do when I get a whole number?
Second number. No. The average between.
Yes, you average that with the next one. So I'm going to average 1, 2. I'm going to average these 2. So pretty cool with that. If I got a decimal, you round up, take that number. So if you get a decimal, there's no averaging to do. You just round up, take that number. Get a whole number, that kind of sucks. Ah, shit, I got to take that one and the next one, average them. Just add them, divide by 2. But here I can see, what's the average of 105 and 107? 106. So Q2 would just be the same idea. It'd be half of 8, right? 50% of 8, which is
4.
4. So that means take 4th and 5th average. And what's the 4th one? 4, 5. What's the average of 129 and 141? Now, real quick, now watch. I think you can throw in your calculator. 129 and 141, the middle number is the same as the middle of 130 and 140.
135.
Yeah, so 135. I like it. So this is 135. Q3, you could do all the work, but look, I had to go 2 in, take the 2nd and 3rd from the top, so here I'm going to take the 2nd and 3rd from the bottom. 1, 2, I'm going to average these for Q3. And of course, 142 and 144 average to be 143. So that's the 5-number summary. I think this is the example. I'm going to use this data in a minute and show you the shortcuts in the calculator to check your work, right? Because it calculates the 5-number summary for us. It shouldn't be that big of a deal. It costs enough freaking money. Now, how do I make a box plot out of this? There's a problem some of you guys have, and that's scale. You're very bad at scale. Scale just means pick an amount that every step means. That's all scale means. So what I want to get from 90 to 144. So what does it make sense for each tick mark to mean? 90 to like 150, right? Mm-hmm. So maybe make each tick mark mean. Yeah, that's a good idea. So 90, 100, 110, 120, 130, 140, 150. So now every data point has a place to go. Now how do I start making this box plot? What do I put where? I put a line at 90. Put a line at
144.
106. So 106 is a little more than halfway. 135. Pop. And 143. Where are you at? 143, about right there. And then 144, yeah. Beep. I'll have to make sound effects. Where's the box part of the box plot? The middle. Q1 through Q3, the middle 3, right? I don't remember if I said this, but what percentage is in this box? What percentage of the data?
25.
Q3 has 75% below it. Q1 has 25% below it. So how much is in the middle? 75 minus 25, 50. This is the middle 50%. It's what I call the heartland, right? So it's like if you see a college saying the middle 50% of our students have a GPA of 3.1 or something, that means that that's the middle, or like it would be from 2.9 to 3.1, some range. That's the middle 50%. That's the heart of their students, right? And then what do I do from here to here? This is really tiny. Beep. Why does that make sense? What's happening at the top of the data that this kind of indicates? What's true about the data points here? They're very... yeah, so just like one problem, they don't vary much. That's why there's not much room there. There's not variation there. Oh, shit. This is flipping huge, right? So there's a lot of variation in the middle. All right, so let's do this. Is everybody cool with that? Any questions on the work involved here? So I'm going to say, find the 5-number summary and create a box plot. Yes?
Can you explain again how you got the Q1?
Where'd it go? Oh, so Q1 is P25. 1 quarter in, so 25% of the way into the list. So 1/4 of 8 is 2. I didn't write this down here, but I got a whole number, so I have to average the second and third.
Is it always going to be like 25%?
Q1 is always 25%. We already said that. Oh, okay. If I say it's the end of the first quarter in this basketball game or football game, or does soccer have quarters? No, they have halves. That's right. Sorry, I'm American. Sorry, we don't know soccer.
So if it's not a whole number,
If it's decimal, you round up, take that number. If it's a whole number, that kind of sucks because you got to round that with the next one. You got more work to do. It'd be awesome to be at 2.1 here, because I'd round up to 3 and take the third number and be done with it. So any decimal you round up, take that number. Any whole number you got to round it. And remember that jives with our idea of median. It's just applied now more generally to all percentiles.
So
Yeah.
Like 2.01, still rounded up.
Totally. It's crazy.
And Q3 is 75%?
Beautiful. Q3 would be 75%. I did do Q3 a different way. But if you don't understand what the shit I did, just do it the same way we did this one. 75% of 8. 3/4 of 8 is 6. Take the 6th and 7th ones, average them, and get the same answer I did. Yeah, because we got 6, right? 3/4 of 8 is 6. Whole number, I got to average that with the next one. Bam. Yes?
On the homework, you're kind of like asking us to describe the box plots. I mean, are you going to do that on the...
I could, totally, yeah. Anything that happened to you in the homework could happen to you in the test. Is that the one that said come up with an idea for what this was? So, just to give an example, somebody said it was the number of times they check their Instagram account or something. So some people don't use it at all, and some people might check it 120 times a day. That makes good sense. It's the number of times you check your Instagram account. You can see the first quartile of the number of times and what's the highest amount somebody checked it. You see, now, I don't want to see like 18 people saying, it's an Instagram account, shit. Make up your own thing, right? Don't steal this poor person's good idea. Let me see what I want.
I have a question about how if we, like, let's say, the person was ranked 58, what's the percentile? How to...
Oh, yeah, so here, if I said, what's the percentile for 129?
Yeah,
It's
but
such-
if you don't see the number, like, you know, you have, I don't know, 200 students, and then you have one person was ranked 8,
Okay,
right?
so we did that problem a little
I
bit.
remember last
Yeah.
time, but it's like, how do you... I can see it, but I'm not sure
So how far was that person away from the beginning?
yeah.
Right. So how far into the list do you have to go? So if they're ranked 37th out of 180, I think was the exact.
Yeah.
Do not divide 37 by 180. That makes no sense. He's not near the bottom. He's near the flipping top, right? How far away from the top is he? 37 away. So where is he then?
143.
143. So you divide 143 by 180. Now the book is a very complicated formula, which is still a true formula, but it's so much bullshit. It's unnecessarily complicates something that's not supposed to be that specific anyway. So in a very small set of data, this is the 90th percent, it's the 85th percentile, it's the 91st percent. It's all these different percentiles because there's so freaking few data points. So why do you need such a complicated formula? And when you get larger sets of formula, their complicated formula, and my way of looking at it, agree. So do you need that? No. If you like to use it, go right ahead. Write it on your formula sheet, like I said. But there's no need for that.
Why did you divide 143 by 180?
That's the next thing to do, of course. Why?
I don't see.
So if I know I want to find the 80th percentile, how do I figure out how far into the list to go? I take 80% of the list size. So think about that backwards. That's how I get to how far I've got to go. So how do I figure out what percent of 180, 143 is? 143 divided by 180. That tells me how far into the list this person is. That's what a percentile means. How deep into the list is this data value? Yeah.
Could you tell us what the box plot tells us, or tells us about the data?
All right, so visually you can see that there's a huge variation in the middle 50%. Right? The most useful thing as far as box plots goes is if I have another set of data. Did I say what this data was? No, I just made this shit up, right? Yeah. Let's say this is, what makes sense here? Oh, that's funny, Jeff. Let's say these are bowling scores for people that aren't terribly great at bowling, right? If you know bowling, well, you know, I would aspire for this, to be honest. I suck at bowling. My little brother has like 12 bowling balls, and he's been in competitions. He's like, what's the lane condition? Oh, I need bowling ball number 3. I'm like, holy shit, dude. It's beautiful math stuff. If I had another thing, so if this is bowling scores for a certain team, and here's another team, here's their box plot, looks like this. Which team seems to be better? This one seems to be better, right? They have, somebody got really high scores, but you can argue that there's not really enough information, but which team has the more variation in their player scores? First one. Did I calculate the standard deviation of it? No, but I can still see there's a lot more variation here than there is here. Right? I mean, look at the middle, it's the little 50% box is so tight that night to night they're very consistent. Here, they're kind of a little bit all over the place. So it's really useful when you have a couple box plots to compare. I like it. I like it. All right, now let me show you, if you want to borrow a calculator to do this with me, anybody want to borrow a calculator? Can somebody figure out which light to turn off? Just turns these off next to the screens. Anybody? Okay. There should be some way to do it. No way? I tried. Okay. Oh, make sure it turns on before you get too far away. Oh, I see. It's. I gotcha. Don't worry. Again, make sure it turns on before you get too far away. Oh, you don't warm up. This is mine. Darn it. You didn't even turn on, did you? Okay, which one are you? that's one of the things you can get from it. You can, I mean, if you had another box plot that was like this for some team, so this is the team that's in a different league, I would say, right? Then it's really obvious that, you know, this team is better than that. When I ask about which team is better, it's hard to say because you don't know how many data points are here and here, right? They could have two really bad players and like a bunch of really good players. And these guys, so then this team is better than that. So there's a problem in the homework that says, where are there more data points? Your right answer is, I have no freaking clue because the box plot doesn't show me that. I like it. Oh, you're finally on. Is it this one? Yeah. I love they have different brands of flesh projector. Okay. On. Yeah. Shit. Let's see.
Are we doing percentiles right now, is what you're showing?
Yeah, I'm going to show you how to get 5-number summary, and I'm going to show you how to get mean, median, standard deviation. Have the calculator do it for you. So you can check the work you're going to do, right?
Can we move the camera to?
Oh, that's probably good. Thank you. Please help me out with this camera.